Hi, welcome back. In this video, we are going to introduce some typical computer network protocols. A protocol is a set of rules and procedures for exchanging information among computers. Just like if two persons want to communicate, they also need to follow the same protocol, which is the language. So if they use the same language, it will be easier for them to communicate. Similarly, different computers also need to use the same language, which is the network protocol. So the protocols define how the communications channel is established and how information is transmitted and how errors are detected and corrected. And usually network protocols are layered, and different layers of the protocol may have different function. So it's very necessary to set up the global standard for the computer network so that the computers can communicate with other computers. So the ISO, which is the International Standardization Organization, established a 7-layer Open System Interconnection Reference Model. We call it OSI model. The objective of this OSI reference model is that for every of the computer that follows this OSI reference model, they can talk to each other and communicate with each other. In the OSI model, we have 7 layers that are the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Because this 7-layer OSI reference model is a little bit complicated, so actually the internet is following this TCP/IP protocol stack. And in this TCP/IP protocol stack, we only have 4 layers. That the network interface layer, internet layer, transport layer, and the application layer. So this TCP/IP protocol stack is actually the de facto standard of the current internet. And in different layers, we have different protocols. Like in the network interface layer, we have the Ethernet, which is the widely used computer network. And in the internet layer, we have the IP protocol, which is also widely used. And in the transport layer, we have TCP and UDP. And in the application layer, we have network, FTP, SMTP, SNMP, etc. So each layer deals with a particular aspect of the network communication. So the TCP/IP is the de facto network protocols for Internet. It's a simplified implementation of the OSI reference model. It has 4 layers. The application layer provides the protocols that the network application can communicate with another application, like the email. You have the email client and the email server, so you have to use the email protocol to communicate between the client and the server. And suppose this is the data you want to transfer from one application to the other application. And if your application uses the UDP transport protocol, you have to encapsulate your data by using a UDP protocol. So you have to put some extra UDP header and encapsulate your data as a UDP data. And then you have to transfer your UDP data through the IP protocol, and then you also need to add some IP header in front of your IP data. And then you can use a network interface layer to transfer the data using different physical media. So here shows you how the internet hosts can communicate with each other. So suppose 2 internet hosts connect via 2 routers and the corresponding layers used at each hop. So from the application's point of view, the application can directly connect to the other application from another host. So the application on each host executes read and write operations as if the processes were directly connected to each other by some kind of data path. But actually, they are not directly connected. The application should send the data to the transport and then the internet and then the link layer. The application cannot directly send the data to the other application layer. So the data from the application will send to the transport and then to the internet and to the link, because the computer is not directly connected to the other computer. Because the host A is not directly connected to host B, they use some router to connect different networks. So here you'll probably use some fiber optical networks or even satellite network. So your link layer will use the Ethernet to connect to the router, and your router will connect you to the fiber optical network or the satellite network. And then it will use the router again to connect to the Ethernet, so that your data will be forwarded to the application on host B. So to improve the efficiency of transferring information over a shared communication line, so the packet switching is usually used. So usually the messages are divided into fixed size numbered packets, and different packets could use different routes. At the receiver side, the message may come in different order, so the receiver will have to reorder the packets and reassemble the message. So the packets are individually routed to their destination and then reassembled. So the reason is that we don't want to send out a large message, so we can just split the message into small pieces, and then you can send out the packets parallelly, and the packets could choose the most available route to send to the destination. So this example shows you how the packet switching works. So suppose you have a message, you can split the message into 3 parts. You have the blue part, green part, and white part. And we call each part a packet. Each packet is addressed to its destination. So in this case, you want to send the packet to UCLA, so you just write down the destination on the envelope. And then you can use the POS system to transfer the packet. And you may have different options to choose the route. For example, this blue packet can choose this route to go to the UCLA, and this green packet can choose this route to go to UCLA. So eventually all these packets will be sent to the UCLA, and when the UCLA receives 3 parts, they can reorder the different parts and then assemble the parts into a message. In the application layer, there are some high-level protocols used by most applications, like the HTTP protocol, which means the Hypertext Transfer Protocol. HTTP is used to transfer the web pages. SMTP, Simple Mail Transfer Protocol, is used to transfer the mail. FTP is used to transfer the file. Telnet is used to remotely log into another computer. And the transport layer provides the end-to-end message transfer independent of the underlying network. There are 2 types of protocol in the transport layer, the TCP protocol and UDP. So the TCP means Transmission Control Protocol, and UDP means User Diagram Protocol. So TCP is a connection-oriented protocol. So it will create a fixed route and then send the packets one by one along the route. So the TCP is a little bit slower because it needs to set up a fixed route, but it is more stable and reliable. The UDP protocol is a connectionless protocol. It will send the packets individually without a predefined route, and then orders and reassembles the packets at their destination. So there is no fixed connection in the UDP. The internet layer will send in packets across potentially multiple networks. So the responsibility of the internet layer is the host name, addressing, and identification. So it will give each of the hosts an unique identification, which is the IP address. It will also have the capability of the packet routing. It will send in packets from source to the destination by forwarding them to the next network router closer to the final destination. And the most important protocol in the internet layer is the IP, which is Internet Protocol. A firewall is also an important component in the computer network. It could be a machine or a software that can serve as a special gateway to a network, protecting it from inappropriate access. So the firewalls are usually used to set up the access control of the network. So here shows you how to use a firewall to protect your local area network. So you can set up the firewall between the internet and your LAN. So with this firewall, it can block some unauthorized access to your local area network. You can use the firewall to set up some inbound rules and outbound rules. The IP address is the most important concept in the IP protocol. Every underlying device will have a unique address, which is the IP address. An IP address usually has 4 bytes and separated by dots that uniquely identifies the computer on the network. So every computer wants to connect to the internet must have an IP address. So it is usually written as a dotted decimal values. For example, here we have an IP address. And for each of the decimal number, we use 8 bits to represent this number. So the range of each of the decimal number should be between 0 and 255. So here shows you an invalid IP address because 312 is not a legal number. The number should be between 0 and 255. The IP address can be divided into 2 parts, the network address part and the host number part. For the network address part, it can contain 1 to 3 bytes, and the rest of the bytes is called the host number. The network address can be used to specify a specific network, so each of the number in the network address part represents for one network, and the host number can represent one machine in that network. And we have 2 special host numbers, 0 and 255. The 0 means the network routing function, and 255 means the broadcast. So usually we don't use these 2 numbers for one particular host. And in the line, you can choose any of the host numbers, only if the host number is different from other machines. But this IP is only for the local area network. It's not a publicly available IP address. For those type of IP, we call it public IP. And public IP can be assigned by the ICANN, which is an organization, and the name is Internet Corporation for Assigned Names and Numbers. So actually, public IP is quite a valuable resource. And as you may know, the IPv4 version already has no available IP address for new machines. So here shows you different type of IP address. We have 5 types of IP address. And for class A address, we use 1 byte for the network part and 3 bytes for the host number part. And for class B address, we use 2 bytes for the network number and 2 bytes for the host number. And for the class C address, we use 3 bytes for the network number and 1 byte for the host number. And class D and E are reserved. It's not a typical IP address. So how do we distinguish whether the IP address is a class A or class B or class C? We could check the leftmost bit. For example, if the leftmost bit is 0, so that means this IP is class A IP. If it's class A IP, that means we use 1 byte for the network part and 3 bytes for the host part. If the left 2 bits are 10, that means this IP is a class B IP. And if it's 110, it means it's class C IP. So we could use this to distinguish different type of IP address. So you may ask why we have different type of IP address. It's easy to understand. For example, for class C IP address, we only have 8 bits for the host ID part. And with the 8 bits of the binary number, we can totally represent 256 different numbers. And for each of the number, it can represent one machine. And because we don't use 0 and 255, so we totally have 254 different numbers. So for this type of IP address, we could have 254 machines in one network because rest of the IP address can represent the network ID. So now we can understand for the Class C IP address, we can use this for small organizations, like a small company that has less machines. So we don't need to give them too many numbers of the host number, because 254 machines will be probably enough for the small company. But if we have a large company or large organization, only 1 byte for the host number part is definitely not enough. So maybe we can have 2 bytes for the host number part. So for this case, we can probably give them one Class B IP network so that they can have more host numbers for their machines. So these are the reasons why we have Class A and B and C IP address. They are designed for different sizes of the organizations. Another concept is called subnet mask. Subnet can organize the host into logical groups to improve the network security and performance. And we can use the subnet mask to split the IP address into 2 parts. And the subnet mask is a bit string. For example, this one is a subnet mask, and we use 1s to represent the network number, and we use 0s for the machine number. So this subnet mask is 255.255.255.0. So how do we use this subnet mask? Let's see an example. So suppose you have a Class C IP address. So that means we use 3 bytes for the network part. And we have 1 byte for the machine number part. That means we have 8 bits for the host number part. And what if we want to split the machines into 2 groups? And each of the small group can be seen as a subnet. So we could use 1 bit to distinguish the 2 groups. So now we use 1 bit here to represent the 2 different groups. So if it's 0, that means the first group. If it's 1, that means the other group. And the rest of the bits are still used as a host number. So now you can see that we use not only 3 bytes as the network part, we actually use 3 bytes and 1 bit as the network number. And we only use 7 bits for the machine code. So now we can use the subnet mask to represent the group. So the subnet mask for this splition is that we have three bytes of ones and another one. Rest of it are zeros. And if we change this to decimal, that will be 255.255.255.128. So this will be the subnet mask for this splition. And similarly, if we want to split the machine code into 4 different groups, then we can use 2 bits to split the groups. So now we have 2 bits so that we can have 4 different groups. And the subnet mask will be 255.255.255.172. Okay, so this is the concept of subnet mask and subnet. So when you see a subnet mask, you should be able to know how many groups we want to split the host numbers. And usually for a TCP IP network, you need some network configurations. And there are 4 key configurations: the IP address, subnet mask, gateway, and DNS server. And here is the Windows network configuration. So we have the IP address here and the subnet mask here, and also the gateway and the DNS server IP. For the IP address, we have 2 versions, IPv4 and IPv6. For the IPv4, we can maximally have 4 billion hosts. And IPv4 has been used up in February 3rd in 2011. But you may think why we can still have more machines and more devices on the internet. That's because the IP address can be reallocated. And IPv6 is the next generation of the IPv4, and it uses 128 bits, so it's not 32 bits anymore. Because we have more bits in the IPv6, so we can represent more machines. And the IPv6 is important, especially in this IoT environment. All of the devices will probably have a public IP. And following is an example of the IPv6 IP address. The domain name is a user-friendly text version of the IP address, because it's not quite easy to remember the IP address directly, but it's quite easy for us to remember an IP address like this. And this is actually the text version of the IP address. A domain name is a dot separated into two or more sections to specify the layered structure, and we can use the domain name to identify one IP address. So for example, this domain name have 4 parts, and CN means the location is in China, EDU means that this is for education, BIT means this belongs to Beijing Institute of Technology, and www means the server or service is 3W service. The very last section of the domain is called the top-level domain. For example, .com or .net or .org or .edu, all of these are the top-level domains. And because the domain name and the IP address is actually organized by the US organizations, so the United States actually owns most of the top-level domain names like the .com, .net, .gov, .edu. So .edu means the US education organizations or universities. .ml means the US military. .gov means the US government. And the organizations based in countries other than the United States use a top-level domain name that's corresponding to their 2-letter country codes, like .au means Australia, .ce means the Canada, and .cn means China. So for university in China, you can use the .edu, .cn as your domain name. Because the domain name actually represents the IP, so we need some place to store the mapping between the domain name and the IP address. The domain names are registered in the domain name system and stored in the DNS server. And currently, the world's root DNS server are located in the United States. But there are some other regional domain name servers in different places. Okay, so in this video, we have introduced some concepts about the network protocol, and we also introduced some important network protocols like the TCP/IP protocol stack, and also some application protocols like the HTTP, FTP, SMTP, etc. We also introduced the concept of IP and the rules of defining an IP address. We also explained the relationship between the IP and the domain name. And there are also many other network topics like the IPv6, mobile IP, network security, VPN, IPsec, VoIP, etc. And these concepts will be introduced in the computer network course. So that's the content for this part.